This model represents a sarcomere, the functional unit of muscle contraction. The ends are the C lines, which anchor the actin or thin filaments. The thicker stakes represent myosin or thick filaments, with heads that form cross bridges. The light purple beads represent actin with binding sites. The white beads represent myosin heads. The teal beads represent troponin. The orange yarn is tropomyosin. The yellow beads represent ATP. Troponin and tropomyosin regulate when contraction can occur. Initially, the muscle is relaxed. Tropomyosin is covering the binding sites on actin, so the myosin heads cannot attach.
When calcium ions are released, they bind to troponin, which would be the teal beads. Tropomyosin shifts. This causes a conformational change in troponin, which moves tropomyosin away from the binding sites, exposing them, which will be the orange yarn. Cross-bridge formation, myosin heads attach to the exposed binding sites, forming cross bridges, which will be the white beads to actin.
The myosin heads pivot, pulling the actin filaments towards the center of the sarcomere. This is called the power stroke. ATP binds to the myosin head, causing it to detach from the actin. ATP is then broken down, re-energizing the myosin head so that it can attach again. This process is called cross-bridge cycling and repeats many times. The filaments do not shorten, they slide past each other. This is known as the sliding filament theory.
As contraction happens, the I band and H zone gets smaller, the A stays the same length. When calcium is pumped back out, tropomyosin covers the binding states again and the muscle returns to its relaxed state. This model uses pipe cleaners for actin, sticks for myosin, beads for trifone, ATP, and yarn for trifomyosin. It helps show the parts interact and move, but it has limitations. It is not to scale, and real molecular movement is so much faster and more complex. This demonstrates how structure relates to function. The arrangement of actin, myosin, regulatory proteins allows coordinated contraction through sliding and repeated cross-bridge cycling.